let me start over again. All right. This is the assignment right here. We're going to multiply two 16-bit numbers. These are the two numbers we're going to multiply right there. I'm going to call this num1 and this num2 right there. So this has to be broken into two parts. Num11 is the 59. Num12 is the A7. This is number 2. Number 21 is FD and 78. So I've redefined those in my code right here. Those are my two numbers right there. 5987 times FD78 right there. That's what I want to multiply. Now, here's the procedure. And another thing for you is you don't have to write this code for the final, but you need to know the procedure. That's there. Which is actually the lab question itself. You need to know how the question is. That's there. So let me go through this procedure right here. Right here. The procedure is fairly straightforward. We've got two numbers we're going to multiply. And let me just do this in one note versus trying to. That's there. So we're going to multiply FD-A7. And what was our second number? Anybody remember? Well, it's 5987 and FD78. $59.87 and FD78. Is that right? Is that what I had here? Okay. All right. When I multiply these, remember that I can only multiply this an 8-bit number by an 8-bit number, right? So let's look at multiplying. This is considered one number right here, right there. Let's look at, we're going to multiply 39 times 52. Normal multiplication, right there. 29, that's 18. We carry the 1, 6, that's a 7, right? We multiply this number times this number, that times that number. We write that down. Then we multiply 5 times 9 is what, 45? So 45. So we put a 5 here, and then we put a 4 here, right? Right there. Right there. And then we multiply this 15, right? So 19. Right there. We end up with something that looks like this. 8, 12, 0, 2. And I don't know if that's the right answer. Hopefully I did that right. Sometimes simple multiplication gets me messed up here. And 39 times, what was it, 52? 20, 28. And I got the right answer. Sometimes, believe it or not, I can mess that up. Right there. Okay, but you see how I shifted this multiplication there, right? We have to do the same thing here. We have to multiply this here, right here, and we're going to get a 16-bit answer right there. So we multiply these two, and we get a number here. That's a 16-bit number right there. Then we're going to multiply these two, and we're going to get a 16-bit number, but it's going to go here. These two are 0, 0. Then we're going to multiply these two, and we're going to get Z, Z, 0, 0. Then we multiply these two, and we're going to get A, 0, 0, 0, 0. Every time we do a multiplication, right there, and excuse me, this is going to be Y. It's better explained here if we go through and look at where it's typed here. You see, when we multiply these two, this is 78 times 59. This right here is 78 times A7 gets us these two 16-bit numbers right there. So what we're going to have to do is we're going to have to store these. We got 1, 2, 3, 4, 5, 6, 7, 8. So let's just store those as we do the multiplication. So our order in which we want to do this, and I'm just going to type this here, right here, is first off we want to multiply, and we're going to multiply num 10 times num 20 right there. And we're going to, right there, we're just going to multiply those two numbers. And then we're going to store those in memory location 30 and 31 right there. Because when we do that multiplication, we're going to end up with a 16-bit number. Now, multiplication is tricky because it requires that one number be in A and one number be in B. And the answer will come out in B and A. It's going to overwrite the two numbers. So let's just go through here. Let's just go back to our code here. Right here. And I can turn these back on later here. Right here. And let's just remove all this add stuff right here. Right here. I'm just going to leave that there for now. But we're just going to go ahead and I'm just going to start writing the code here. We're going to multiply first these two numbers, the lower 8 bits, and we're just going to see what happens there. So let's move into A, R5, move into B, R7. Right there. And multiply AB, right? Right there. And let's make sure, let's look at the multiply command. It doesn't hurt to go ahead and just look at the multiply command. I think I actually sent that out on Facebook to everybody, the multiply command, to recall. Oh, I didn't watch the football game yet. I don't want to know the score yet. Where's my groups? Oh, here's my groups. Okay. Here's the multiply command right there. So I'm just pulling this off of here. Multiplies 8-bit number in the accumulator and the B register. The low 8 is returned in the accumulator. The high order byte is stored in the B register. So, and the command is just simply multiply AB. So let's look at what happens here when we just run this right here. And let's go ahead and view. Let's turn on registers and turn on the processor. Right, I don't want that one there. I want view. That should be it, microcontroller. Yep, there we go. So let's go through it and start single stepping through this here. All right, we move into R4, our first number, R5, R6. And we move into A, R5. So A is A7. We move into B7, 8. Go back to we're multiplying A7 times 7, 8. Right there. We do our multiplication. In there we've got 4E48. Is that what we expect to get? 4E48 right there. So we've got 4A and 48. So we got those two numbers. We need to store them someplace. So, and I'm just saying for sake of argument, let's just start storing at 30 right there. Because if we look at our map, that's there. So let's just go ahead and let's store those numbers. Move A to the 30A and move to 31B right there. Because later on, we're going to have to add them up in a certain order and store them right there. So, project debug, view debug windows, and we want to look at memory, RAM, right here, so that we can see that our numbers are stored down here. Location 30 is where we're going to expect to see our numbers stored down here. So let's The 30 contains, and why did we not see our memory locations change? That doesn't make sense. All right. Let me look at my map again here. Make sure I didn't do. Make sure I didn't do something funky here, because that should work here. You know what? Direct and indirect addressing. Yeah, 30 is a good memory location right there. And we should be able to access 30. Oh, hold on here a second. Brain malfunction here. Forgot the hex right there. Right there, we forgot the. Yeah, okay. There's our. Memory location 30 is 484E, and that's expected to be. That's there. Now again, I think we might, for sake of argument, we may all reverse those. Put those low order byte first, right there. So I'm going to move. No, hold on. A is the. As I said, so I didn't write this ahead of time, so I'm writing this here. The high order byte is returned in the A-B register. Okay. So that should be right. Our high order byte is 4E. 4E is in B register. 4E is in location 31. Okay, that's right. It's just it looks a little funky because those are written in backwards right there. The high order, this is actually 4E48 right there. So all right, so we did the first one. Now we're just going to repeat this for the next one. So now that we've multiplied we've multiplied at this point 1 0 and 2 0. Let's go ahead and multiply 1 1 times 2 0. So move A, and 1 1 is R4. Move B is R7 right there. Yeah. Okay. Because what we want to multiply at this point here, let's go back to the instructions. We want to multiply 70 times 59. 59 is num11. Num11 is in R4, right there. And num120 is R7. So again, we go through and we multiply AB, and then we store the results. Move A to 32 hex, and 32 hex, A, and move B to 33 hex, right there. So we're going to go through and we're going to move A and B, and at that point, if I run this again, right here, single step, I'm going to go ahead and put a breakpoint here. That way I can just run to that point right there. So I'm going through and I'm multiplying, moving those to the registers. Move A7 to A. I move R7 to B. I multiply the two. I store. I store those two. Those are still the same. Now I'm going to move R4 to A. There's our 59. There's our 78. We multiply the two. There's our, again, our result should be 29B8. And we got 29B8. See that right there? So then we move those to our two memory locations right here. Right there. So we've stored that. So we repeat that, and I'm just going to that there for the next two. Move into A, and now we're going to multiply right there, and this is where things get a little tricky here because I got the screen. Now we're going to be multiplying FD, which is 22 times 10. 22 times 10. 22 is 22 we put into, or 21, excuse me, FD is into num21. So that's R6 right there. Move to B, and at that point we're going to be moving to R5 right there. Go ahead and multiply AB right there. And capitals don't make a difference right there. And then we're going to move to 34B and move to 35. And let's put the H's there before I. Hey. You know, let's just go through here and we're just going to step through there and see whether we're matching the results there. We know that that part works because now we've got 4E, 4/8 there, right? Right there, and then 2938 here. And we have 0BA5. Is that what we're supposed to have? Looks like I got the 0BA5. Is that right? That's the right numbers. Do I got them in the right places? No, I don't have them in the right places. It looks a little weird here. I need to, right there. See, that's why you go through this step by step. Okay, as we go through here, I'm just going to go all the way to the end here, just simply right here. And now we look here. Here's our A50B right there. We're almost done with our multiplications, right? We've done 1, 2, 3 multiplications. We got one more multiplication. So our next multiplication, we're going to be multiplying here 1 times 2, the top two, right? So we're going to move into A, R4, move into B, R6, right there. Multiply AB, move, and now we're going to go 36 hex A, and move 37 hex B, right there. And I'm just going to put a breakpoint here and just run to the end here. No sense single stepping through here. Right there. And let's see what we've got here. We've got 57 F5 there. And we should have 57 F5. So we've got all of our numbers. Now we can start adding them up and storing them in the registers where they're supposed to be. So we've got to add 3 numbers together to get, or 2 numbers to get right here. Now, I can't necessarily write on here, but this is, when we look at this graph right here, these 2 numbers, and if we look at these locations, we've got this number is right there. So we can just move that one right there. So we're going to store these in order of R0 through R5. So this location right here, 48, can just be moved straight to R3 right there. So as we look at this here, and this location can move straight to R0 right there. So when we look, as we look at this right here, and let me just copy this right here, and let me all right, now I can write on this here. Okay, well, let's just look at what we got here. This is num1, right? 1. This is num2, right? This is 1, 1, 0 right there. Right there. Now we stored these right here. 48 is stored in location 30, right? The 4E is in location 31, right? The B8 is in location 32. The 29 is in location 33. The F5 is in location 34. And these are all hex. Right here. Right there. The 5-7 is in location 35. Right there. Now, hold on here. I made a mistake here. I missed one. Let's start over again here. All right, the first two we got right. So this should be B8 is in location 32, right? 29 is in location 33. 0B is in location 34. A5 is in location 35. C4 is in location 36. And 5-7 is in location, what? F5 is in 36. Yeah, okay, I'm looking down at the green, F5. And then 5-7 is in location 37. Right. Now, the problem is we need to add these up. Right there. Right there. So this one we can move directly. That's not a problem. We can't move this one directly. And the reason we can't move this one directly is we have to take into account if there's a carry. Right there. So this goes to R3, R2, R1, and R0, right? If we follow the directions. So now we need to start adding the results. That's there. So when we go and we add the results, first off, we could just move the 48 straight into R0, right? Let's just go ahead and do that. Move to R0, and that's memory location 30 hex, right? Now we have to add the next three together in order to get the next spot. So we have to move right there, and we're going to do a 2-bit add, or a 2-number add right there. We need to add 3 numbers together, and they're all 8-bit numbers. So we just simply do the add right there. Now we have to take into account if there's a carry out, and this makes it very tricky. But right now we're not going to worry about the carry out. We're just going to add the 3 numbers. So let's move into A, memory location. And what memory locations are we adding right there? Right there. We're adding memory locations 31, 32, and 34. 29 we don't add. That goes on to our next add, right? And this is where things get a little tricky. To add these 3 numbers, that's memory location, and I'm looking at the numbers here. 31, the B8 is 32, and the 0B is 34. We need to add those 4 locations right there. So when we add those 4 locations there, we should keep in mind that we may get a carry out. That's there. We will get a carry out. So we'll get the wrong result here, and we'll see if we can figure out how to handle the carry out. Right there. As I said, I didn't write this. I'm writing this in front of you right there. So let's go through and just add those 31, 32, 34. Let's move 31 hex. Let's add a 32 hex. Add a 34 hex. Let's see if that works. Right there. Okay. First off, R0 contains our 48, right? That we should get, right? Now our accumulator we've added right there. We've moved it. Let me stop this and let's put a break point and let's reset, rerun it right there. Okay, at this point we're going to move into R0, R48. That's fine. Now we move into A, location 31. That's 4E. Now we're supposed to be adding here 4E to 48. All right? We do that. Now, A contains 11. That's good. The reason that's good is because the carry kept on is through there. Now, hopefully our carry, but again, the problem maybe is our carry flag may have been lost. We'll find that out in a minute, because let's go ahead and move this 11 now to R1 right there. That goes to R1 at this point, right? Let's move R1A. Now, at this point, we need to move back into A. What do we need to add for our next group right here? Our next group is 29. That's location 33. I'm doing this one right here. 33. A5, which is 35. And F5, which is 36. So those are the three locations, 33, 35, and 36. Right here at this point here. But this time we're going to move, so 33 right there. Let's add with a carry a 35 hex and add a 36 hex. Let's see whether or not that works there. Okay. Step through. Right, R0 contains our 48. That hasn't changed. We move 31. We're doing our add. And we got our 11 now in R1. And we move into 33 into A, which is now our 29. We add with carry there, and then we add the next one. That's C3. What should we get here? C4. Our carry got lost. And the reason our carry got lost is because our carry occurred when we added the first two. Right there. And that's a carry out. And we can't do an add carry there. So what we have to do is if there's a carry out, we have to increment something. Right there. See, we have to do a jump if no carry and then add one to the something in order to add it back in. The carry gets very tricky when we add three numbers. That's there. See, if we reverse the orders of these, see here we're adding 4E to 8B. When we add those two numbers together, that resulted in the carry. When we added that result to the 0B, that didn't have a carry out. So that's the problem is the carry is lost on the second add. And we just can't follow with two carries. That's why this problem is actually a very difficult problem. Right there. And that's why I'm sitting here going through it with you so that you can see the process. I'm not expecting you to remember enough to write the code. I'm expecting you to at least regurgitate the question. And when I say regurgitate the question, store the answer, right in this way. In other words, outline the steps. You don't have to worry about how you would write this code, where you would add these numbers up like this right here. So how are we going to handle the carry? We have a command called jump no carry, right? That's there. So if we look at the increment command, what's our options on the increment commands? Right there. Let me pull up the instruction set. Let me pull up the instruction set here. Instruction set. And let's see what we can do with the increment. Move, we don't want to move. Here, I want to find the decrement. L jump. Jump carry. All right, we've got that command right there. What I'm looking for is the command for increment. The easiest way is as soon as I find the increment command, logical and decimal. Divide, increment. Increment data pointer, decrement byte, increment byte. Okay. Now this makes our life easy. And the reason this makes our life easy is that I can increment one of the memory locations to solve that problem. Right there. So I can increment the next memory location. So we go back here and let's look at our code here. Right here. We're going to be adding, let's go back to our OneNote here. We're adding locations 33, right here we're adding locations right here, 31, 32, and 34, right? And then we're going to add these two. If these two result in a carry, then I want to increment either locations 33, 35, or 36 right there. So let's go back to our code, and you'll see what I mean there. Right here. Here we're adding 31 and 32 right there. We're adding those two there. That resulted in a carry, right? And a carry was lost. So let's do a jump, no carry, to don't. And then I'm going to say don't add, do not add 1. You know, that's just a label right there. Let's just do an increment. Make sure I get the command right. Here. INC. INC 33 hex right there. Do not add 1. Right there. So what I'm doing right here is that if I don't have a carry from those two adds, I'm going to skip this increment. Otherwise, I'm just going to increment location 33 in order to handle the carry that way. I'm just going to add 1 to one of the numbers I'm going to add up here. Now, the problem comes in. Let's go back and look at this here to see if that's going to create a problem. No, it's not, because I'm only using that area. Yep, so that's not going to create a problem right there. So I'm just going to, so if I get an add here, this location 33 should go from, is it what, 29 is 33? 29 is 33. So that should become a 30, or 2A at that point. So let's see what happens here. And I'm just going to put a break in there so I don't have to go through here. So we go through and we do that multiply. You know, we're going to move 36, you know, oh, no, I'm down here at the add. Okay, my multiplies are fine. So, right here. Now I'm going to increment 33. So now it's 2A. So I've added 1 to that there. Now when I step through here, right here. Now when we look at my registers, what do we have here? That's our 11 right there. In our, well, we haven't stored the results yet, right? Right there. A is now C4. And it should be C4. So we now need to move to our 2A. Right there. So now as we're looking at this, we've got, so far if we look at our solution, we're supposed to get 5, 8, C4, 11, and 48. So now the only thing we've got to do is we now have got to add the last 2. Right there. And then, as I said, we couldn't just move that there. We couldn't just move it there. The reason we couldn't just move it there is because as we looked at this is 57 and became 48. We had to carry out of here, so we have to do the same thing. Right there. We have to look to see if there's a carry, and then we also have to put when we do the last add, we also have to look for a carry. We have to look for a carry. If there's a carry anywhere in this add, we need to increment this memory location. So all we have to do here is, again, here we add with carry right here. Right there. Let's move this right there. Now here we did an add with carry. I don't know at this particular point. I'm not going to do the add with carry there. I'm going to do the same thing here. Add and do a jump no carry. Do not add 2 and increment 33 hex again. Do not add 2. Right now, okay. Now we're going to do the same thing here, and I'm just going to be looking for a carry out right there. Let me make sure I didn't break it here. And we're left with C4, 11, and 48. Now what we need to do here is we now need to look for a carry on these 2 adds. And probably the easiest thing is to just do the same thing as I did there. Jump no carry. Do not add 3. Increment. And that's memory location what? Or 57 is in location 37. 37 hex. Do not add 3. Hold on here. Hold on, I messed something up here. Move 33 to A. This is in the wrong place. Cut. Sometimes we make these mistakes here. It's after the add. Add, jump, no carry, increment. Do not add. 3. And we do the same thing, we repeat this again. Jump, no carry, do not add. And this should increment location 37. Okay, let's look to see what I did here. That there before we test to see. And this should be R0, R3. Move R. All right, let's make sure we did this right. The first one goes R0. This goes to R1. This goes to R2. And then to R3, we're going to move location 37 hex. Okay. All right, let's look to see what I did here. Let's compile it, see if I didn't break it. Oh, I broke it, something. We're increment. That there. Okay. Let's go through the code and see what I did here. And again, that carry, because we're adding 3 numbers, cause all kinds of problems. That's where assembly language programming, and this is your first real shot at looking at a complicated program. That's there. So the problem is that I'm adding 3 numbers. If I have a carry in either of those 3 numbers, I have to do something with it. So I have to look. I add those 2 numbers. If there's a carry, then I have to deal with it. Same thing, I add those 2 numbers. If there's a carry, I have to deal with it. I add these 2 numbers. If there's a carry, I have to deal with it. And the way that I'm dealing with it is I'm just incrementing one of those memory locations. That's there. Now, I could just run this right there. We can't just run it. We need to put a stop there. And we can see whether it works right there. Our answer is 58, 26, 11, 48. Is that the right answer? 58, C4, 11, 48. That is the right answer, isn't it? Well, no, it's not. I got a 26 in R2. How did I end up with that there? I did something. I got something in the wrong place. Let's go through it from the beginning here. The first thing I did is I moved 30 that there. That's fine. R1. I moved A. Okay, do not add increment 33. Add those 2 together. Do not add 2. Increment 33. Move R1. R1 11 is okay. Now the next one. move 35, 33 into A1. Do not add increment. I forgot somehow I'm not moving. Oh, here I'm moving R2A. That looks like that 26 is not right. That should be C4. We had C4 a few minutes ago there, so I broke something up there. All right, well, all comes into play. Let's see what's going on here. Right there. Increment at 33. A. I got 26 here in A at that point. Okay, all right. I'm not seeing where I broke it here. Let's go through the logic again here. This we know is right. This we know is right. This no. Increment R33 and move A. All right, let's see. Make sure this is right here then. Move A R1 has got the 11 there, right there. There, I move in the A33, memory location 33. That's our 2A. We add to it memory location 35. We do a jump, no carry. I got CF there. I don't add, and then I add memory location 37. Memory location 37 is not right. That's my problem. Memory location 37 is not right. Because I'm supposed to be adding here memory location 36. 33, 35, 36. Right there. 33, 35, okay. My screen just went, oh, you know what? I plugged in my charger, but I didn't connect it to my laptop. That's why my laptop is going into power saving mode. Okay. I think we've got it right here. Let's try it again here. You know what? I'm going to step it through step by step here. You know, let's do it once. Let's see if it's got the right answer, and then we'll go step by step. All right. We've got 4811 C4 58. The right answer is 58 C4 11 48. So we got the right answer. We finally got through this problem. We finally got through this problem. That's there. As you can see, it's a major problem. But this is the type of thing. We're okay. The multiplication is easy. Here, all we're doing is moving our numbers around right there. This is our first multiplication right here. right there. And normally you would put comment multiply m num 10 plus and num 20 right there. Now we're going to multiply num 11 and num 20 right there. I'm just putting comments right here so you can see what's going on as we're going through here. The next one right here is we're going to multiply right here, multiply in this case we're going to be multiplying num 10 and num 21 right there. Hopefully I got that right. And then the last multiply right here multiply num 21 and num 211 right there. I guess be consistent here. 11 and 21. So there's our, and actually we've got another multiply right here. There's a multiply in there. There should be 4 multiplies right there. Multiply, this one here should be, this first one is 10, this should be, all right, why have I got an extra multiple? There should be 4 multiplications. 10 and 20 right there. Then we're multiplying 11 and 20. Then we're multiplying right here 1, 2. Looks like there's an extra multiplication in there. There should be only let's try to comment there. Up there. There should be 2 multiplications, 4 multiplications. This one times each of these, and this one times each of these. I got the right answer, so how did I make a mistake? Unless I'm doing something twice. R0, R5, R0, R5, okay. Oh, this is in the this is the start of the add. Okay. There's our multiplies. Okay. Now here we start our add right here. Say lowest 8 bits right there. And here's our adding. Right there. Okay. Now, let me make sure I didn't break it here. Okay, I didn't break it. Okay, the reason I did that is to kind of show what's going on here. This here, all we're doing is we're just defining our numbers. So if I want to, we're putting them in the registers there, and actually we don't, we really don't even need to do that because we actually, this is where we store our numbers to begin with, right there. This is our initial storage right there. And we're just grabbing them from our memory right there. So, and then we store the results in our memory locations after every multiply. So we start off with our numbers in our registers right here. There's the numbers in the registers. We end up with our results in the registers. So our original numbers right here start off as 5987. They're right here, 5987 FD78, right there. So there's our original numbers right there. Those are our original numbers, and then the answer ends up in the back, and they're actually in reverse order in which way we put them in. Not there, but we end up with that result there. So as we go through and we execute our code, we can see that what's going on there. It's one step at a time. You know, all we've done is we've just stored our four numbers. We move R5 into the accumulator. We move R7 into B. We multiply the two. We store the result in the two memory locations. We do the next two multiplications right there. So we're going through our four multiplications. That's the easy part. The hard part then is figuring out how to add. Moving R0 to memory location 32 right there. Right there. So we've stored R0 there. Now we start doing our adds. And our adds are easy except for the fact that we have to worry about the carries. Right there. And we end up with our result here. Our result is 58C4 1148. If we want to try a different set of numbers, we can just change that to 7, 8 right there. And I'm just going to put a breakpoint. You got to download before you put the breakpoint. And we can run that right there. And we've got a different set of numbers, 77, 75, 99, 48. If that's the right answer, hopefully it is. So that's how you would do that problem. Now you have to write the report for that. Now I'm going to make life easy. I'm going to go ahead and copy and paste this right to the Facebook page real quick. That way you can go through and step through this. And actually, we're about out of time for the day. That there's 3:30. You're not going to have time to do it. But and Wednesday, from what I understand, there's a open house Wednesday afternoon and I have to let you guys go by 1 o'clock. Or no, by 12 o'clock, right? I have to let you go. So we lose an hour of Wednesday's lecture. That's there. So Wednesday, what I want you to do is come in here and be here right at 11 o'clock or 11:15 and go through and walk through this program. Because you're going to be expected to explain to me what it does and how it works. You don't have to write it. But I'm not going to make you. Let's do a Control A, Control C, and I'm going to be a lazy person. And right here, write something. Submit the report. I would have to say sometime before the final exam, next Monday or Tuesday. Right there. What's that? Hard copy. Just drop a hard copy up on the office now. You may, if you can bring it to the final and just turn it in as you come in for the final exam. I'll be there. I'll collect them here in the final. That might be the easiest time to collect them. Just turn them in when you come in to take the final. This needs to be individual. That's there. And I just posted the code up. But what I want you to do is to spend a little bit of time that you should see on the code. I thought I just posted. Yeah, there it is. You should be able to just cut and paste that right there. Now, I don't know why some of that's blue, because it was probably highlighted right, because they're numbers. You should be able to just cut and paste that and run that there, and just kind of single step through this, and just make sure you understand how it's going to work. There'll be a question that says, explain how to do this. Right there. Obviously, it took me an hour and 15 minutes going through explaining step by step how to do this. Yeah, the hard part is the adding, because of the three numbers you add. If you're only adding two numbers, you add with carry works fine. Because we're adding three numbers, we have to catch the carry on either of the two. And the easiest way to do that is do the jump no carry and increment one of the other memory locations. So assembly language programming is not obvious to most people when they first do it. It should appear to most of you that I've done this type of program before, even though I have not done this one. I've done these kinds of programs before, so there's a lot of experience. I normally, in a class where we had lots of time and people were expected to work outside of class time on labs, in other words, open labs, I would just assign this to walk away and let you guys become bald, pull your hair out. So, with that said, I'm going to stop the recording. I actually talked a lot longer than I expected to. Yes, you had a question? For the first B and C is in one report. Well, A we didn't do. Just B and C.